Iron, gold, copper. Minerals are the lifeblood of the world's economy. From the Arctic Circle to the Sahara Desert, the $1.7 trillion mining industry supplies raw materials needed for everything, from skyscrapers to smartphones. But mining also comes with an increasingly critical environmental cost, one that may require us to think about off-planet solutions before it's too late.
Booster ignition.
Asteroids, moons and planets in our own solar system hold an essentially unlimited supply of untapped resources.
The first trillionaires will be those who mine asteroids.
Resources like gold, platinum and rare earth metals make some of those asteroids incredibly high-priced. But the most valuable element may be our most basic one.
What you want to mine in space is what you need a lot of.
And while humans have been mining for thousands of years, mining in space requires new, innovative technologies to realize any potential business and economic opportunities. Such technologies might just allow humanity to expand operations off Earth and take that next giant leap. These tiny dots represent the millions of asteroids in our solar system. Over the past 2 decades, government and private aerospace companies have been investigating their composition, location, and even possible payoffs to mine them. This one, known as Bennu, has an estimated value of $669 million. Ryugu, $82 billion. Better yet, an asteroid called Davida, which is valued at more than $100 trillion. And the reason for these high price tags? They're made up of valuable metals like platinum, gold and iron.
We believe that asteroids have platinum group metals, rare earth metals in higher percentages than you might find on the moon, for instance.
Only once in human history has an asteroid sample been brought back to Earth, on the Japan Aerospace Exploration Agency's Hayabusa mission in 2010. And even then, the return sample was merely dust particles. And the total cost of that mission? Approximately $250 million.
One problem is that compared to the moon, there's very little gravity. So somehow you have to attach yourself to the asteroid, whereas on the moon, the gravity will hold your processing equipment in place. So the general answer to the question, can we bring materials mined in space back to Earth? The general answer is no.
Bringing things from space to Earth only makes sense if what is retrieved is so extraordinarily valuable and just not available on Earth.
And even returning the most valuable asteroids could drastically devalue those materials. Take asteroid 16 Psyche, for instance. NASA is constructing a probe to launch in 2022 to study the potato-shaped object, which is roughly 95% metals, nickel iron, platinum and even gold. Some estimates value the asteroid at $700 quintillion. NASA says it may be the inner core of a developing planet that somehow lost its outer layers, offering incredible insight into how planets are formed. If someone did manage to bring large amounts of this asteroid back to Earth, supply of the resources would skyrocket, meaning we'd have more of the material than we would have use for, causing the price to crash to almost zero.
Once we erode the rarity of a high-value metal or mineral, the value of that terrestrially could drop significantly.
Experts agree that a more likely scenario is materials mined in space will stay in space, jump-starting a whole new money-making industry.
Any spacefaring nation will have looked at what's called in-situ resource utilization, which is a very common space term, meaning you use the resources where you are. So taking that model of if you need it in space, mine it in space, what would you be mining? Mostly you need fuel.
There's something else much more valuable for use in space that's abundant on Earth. Water. Not only can water sustain human and plant life for future manned space missions, the components of water, hydrogen and oxygen, can also be separated and reassembled to make fuel. This zero-emission fuel, called hydrogen fuel, is the same used in spacecraft propulsion and fuel cell vehicles. Hydrogen fuel research in this new space race could also spur new technologies that can help fight climate change by speeding the elimination of fossil fuel use on Earth. And there's already a high demand for it, and an immediate business opportunity for risk-tolerant companies wishing to make a fortune. In a 2018 paper by industry, government and academic experts, they estimated that for an initial $4 billion investment in a moon water mining operation, which is about the cost of a luxury hotel in Las Vegas, about $2.4 billion in revenue could be generated annually.
The sort of business case 101 for mining in space is, if you're going to launch something from Earth, it's going to cost you about $10,000 or $20,000 per kilo to get it into space. So if you need water for something in space, and you can produce it for less than $10,000 a kilo, then do it in space. The United Launch Alliance, ULA, they have put a price on water in space. They have said, we'll give you this amount of money for the water, which means people who are going out and trying to produce that water now have a customer.
In 2016, the ULA announced it's willing to pay around $3,000 per kilogram for propellant in an orbit less than 2,000 kilometers in altitude, called low Earth orbit, compared with the estimated price of $4,000 per kilogram to deliver the propellant from Earth. Most experts believe the Moon is a logical starting point for this. It has more gravity than an asteroid, making it easier to land, and its poles are thought to hold vast amounts of water ice. That potential volume of water has made it the focus of NASA's Artemis program, which aims to land astronauts on the Moon's southern pole and also make the space agency a critical first customer for any water harvested on the Moon.
China, India, Israel, the US, Europe, everyone is now sort of focusing on the Moon.
And all of these government programs are looking to set up shop for a water mining future. A fueling station on the Moon could ultimately make current space ventures much cheaper and make future space missions possible. Although entirely theoretical at this point, here's how it could play out. Water is mined on the Moon and a fueling station is set up. This would provide the first customers, most likely government agencies, with water for human consumption and fuel for spacecraft. Water-derived fuel could also be harvested on an asteroid. Vehicles or propellant transports then carry the fuel from the surfaces to a stable storage point between the Earth and the Moon. Fueling stations can also be set up in low Earth orbit, making it accessible to satellites and other spacecraft. As of now, satellites that run out of fuel are decommissioned. Extra fuel would allow them to stay in their orbits, increasing their lifespan. Since using a rocket to get fuel out of Earth's atmosphere is expensive, refueling in low Earth orbit can greatly improve the size, type, and cost of missions in space. The commercial launch industry like SpaceX would also benefit from these fuel depots. The use of lunar-based propellant and commodities may also provide a stepping stone for interplanetary exploration. But while there has been a renewed interest in the Moon, it hasn't been easy. In just 2019, missions to the Moon's surface by both India and Israel resulted in landing failures. And the technology to mine and extract these potential water reserves on the Moon and beyond is still unproven. But some entrepreneurs are still optimistic.
The answer is yes. The technology exists. We can put something together, we can send something to the Moon that can mine water. So we are sort of like a trailblazers, trying to figure out what's going on the Moon, what's below the surface.
Meet Honeybee Robotics. They've designed drills used in NASA's past Mars missions and have sampling and mining systems going on future planned missions to the Moon, Saturn's moon Titan, Mars' moon Phobos, and Jupiter's moon Europa.
We've been focusing on developing high-end, fully autonomous drilling systems from literally iPhone size all the way to the size that cannot fit inside this vacuum chamber behind me.
And that's why NASA has long relied on their expertise. Unlike your everyday drill from the hardware store, their drills overcome the numerous limitations of space, which include extreme temperatures and low gravity.
That means you have to be very, very imaginative, very innovative to solve these problems. You're essentially trying to do what we do here on Earth, but with a fraction of the power, with a fraction of the mass, with a fraction of the volume, and drilling is unforgiving. If you get stuck, if something goes wrong, there is no second chance.
The difficulty in drilling would delay placement of the second probe until the next day.
One of their innovative ideas, called PlanetVac, uses compressed gas to shoot material into a sample container. Its ergonomic design allows it to be inside the foot of a lander, and was chosen to go with NASA-funded payloads to the Moon and Mars moon Phobos. For mining and extracting water on the Moon, they created the Planetary Volatiles Extractor, or PVEX, and it not only drills, it mines. It's based off a drill that removes a cylinder of material called a coring drill.
But it's not just any coring drill, it's a system with heaters on the inside. So you drill down to required depth, you heat up the material that's on the inside of a coring drill, and ice turns into vapor, and vapor moves up the coring drill into a cold finger. So you're capturing water vapor like, for example, in your freezer when you have condensation. PVEX is a mining system. It can actually get into the soil, it can actually extract water, it can actually capture this water in a separate container. We have all the pieces together and we can go to the Moon or Mars and mine it.
When it's tested on the Moon, which may happen in the next couple of years, PVEX will be the first end-to-end mining system deployed in space. And they have even more futuristic ambitions to use the PVEX drill. Like this one, that not only extracts and stores water, but uses it to propel itself, like a flying kettle.
WINE, it stands for the world is not enough. It's a James Bond stuff, it's very futuristic. It's a new concept of space exploration.
The main idea is to send hundreds of low-cost WINE spacecrafts all over the solar system to give a clear atlas of asteroids that have water resources. Honeybee Robotics is one of the many startups that NASA is depending on to develop new innovative ideas.
There is a strong private-public partnership with NASA right now to come up with landers that we can send twice a year, that will put payloads to the Moon, payloads like instruments, like rovers, and also humans. We're doing it. It's happening right now. Very, very exciting times.
By giving out multiple contracts, NASA reduces the cost for themselves and the entire industry.
We want to have numerous providers that are competing against each other on cost and innovation, driving down the cost and increasing access to space and industrializing.
Startup TransAstra, with a new infusion of $2 million from NASA, has teamed up with other space startups and educational institutions to prove its process for harvesting and utilizing water from asteroids without even touching them.
Optical mining is our patent-pending process for using highly concentrated sunlight or light from another source to excavate the surface without having to use digging tools to dig into it. And this is very important in space, especially for asteroids.
To help develop and prove this technology, they've teamed up with the Colorado School of Mines. It's known as the Optical Mining Testbed. First, they put the simulated asteroid in a vacuum chamber to recreate the conditions of space. Then, they use liquid nitrogen to cool a surface inside the tank called a cryotrap. Then they turn on a giant light bulb, which imitates sunlight that they then concentrate into a beam, resulting in very high temperatures. The beam of light hits the asteroid target, fractures the sample, and then water and other materials are released and frozen onto the cryotrap.
The volatile materials, which include water, methane, carbon dioxide, other valuable materials that are common and cheap here on the ground, but very valuable in space, trapped on our cryotrap.
Well, that's pretty nice.
The same way that we would trap those chemicals in space for a real asteroid mining mission.
Optical mining bypasses the daunting task of trying to land on an object with such low gravity that it could simply break apart when touched, and there's no drill to potentially get stuck. But for this to work, they're targeting smaller asteroids the size of a beach ball for their tech demonstrator model, with plans to accommodate rocks the size of a cubic tennis court and bigger in future models.
We think the right thing to do is to rendezvous with the asteroid, match rotation with it, put a thin film bag around it, cinch that bag down, and then de-spin the asteroid. And now you have the asteroid in a container, so you can work with it in a practical way.
TransAstra believes that harvesting water on asteroids will not only make space travel more affordable for private industry, but it will make NASA's proposed missions to take astronauts to the Moon, Mars, and even asteroids possible within a budget that the US Congress may be willing to provide.
Now we can cut out hundreds of billions of dollars and actually make it possible for NASA to do all those exciting missions in a period of just 20 years or so by harnessing the asteroids. Now what's really cool about it is that by using public-private partnership and working with companies like TransAstra, the infrastructure for space resource harvesting and commercial transport in space can be developed. So by NASA doing it this way, and NASA becoming the first user of these resources and this infrastructure for its exploration missions, then that infrastructure is left behind for industry. And that can create massive industries in space. Like it even becomes cost effective to build a space hotel.
TransAstra and partner Momentus will be on a 2-year contract with NASA to build their asteroid mining and in-space transportation prototype called Mini-B to provide optical mining in space.
We live in a very exciting time where we're going to be able to take that to space, and the resources of space are literally unlimited.
And those unlimited resources are what some universities are betting on. At the Colorado School of Mines, where TransAstra does its optical mining research, they now offer a graduate degree in space resources.
Our space resources program is the first of its kind in the world. There is anticipated to be a growing number of jobs directly in space resources. But the skills and practices of space resources can be applied to lots of other things.
And a huge benefit to space mining research is that a lot of this technology can be beneficial here on Earth. Like their 3D printer that uses materials on the Moon or Mars to make structures, and is modelled after startup Icon's 3D printer that is used to make homes on Earth. Their penetrometer is a tool on the end of a robotic arm that's being developed to take measurements on the Moon, but has applications for mining companies. And even a rover in a lunar testbed that can drill and prospect for resources has its benefits.
There are places on Earth where mining companies and equipment manufacturers are looking at applying smart robotic systems in terrestrial mines. They could go into places that are not safe for humans. They could work in much more confined, toxic environments than a person could.
And one country is doing just that, and hopes to leverage their expertise in robotic systems for mining remote, inhospitable locations that are almost Mars-like.
Recently, the administrator of NASA, when the head of the Australian Space Agency visited, was saying that the US is looking to Australia to be doing development in this area of extracting resources in space. One of the reasons why we in Australia want to get into this area is because of the strength of our mining industry, the strength of our mining automation, and the strength of our mining research. We see it as a way that Australia can establish a niche space capability.
Australia's high wages have caused some of the largest mining operations in the world to seek cost savings by using automation. Rio Tinto, the world's second largest mining company, has fitted operations in Australia with fleets of autonomous trucks, drills, and even the first driverless freight train network. Adapting these technologies could prove useful to space programs, and the use of space technology in mines, such as robotics, would be useful on Earth. The Australian Centre for Space Engineering Research at the University of New South Wales in Sydney was founded in 2010 and has 15 PhD current or graduated students researching space resource ventures related to Australia's needs and expertise.
What we are trying to do at the moment is to reduce the risk perceived by a large company, mining company for instance, when they approach this type of venture. I think one of the main reasons that terrestrial mining companies should be looking at this problem is that they will benefit their terrestrial operations by learning some of these lessons. So if they look at the way that you need to automate on the moon, that will help their terrestrial operation. If you look at the way you would analyse risk for this type of mine, they must learn new lessons, which should hopefully flow back to their risk analysis for terrestrial mines.
Although mining companies have terrestrial mining expertise and monetary advantages, only time will tell who will be the first to provide a fueling station in space.
In terms of making it happen, I actually don't think it'll be a startup, I don't think it'll be a space agency, and I don't think it'll be a mining company, but I think it will be a big company, probably driven by a high net worth individual. A company like Blue Origin, SpaceX, a company like that. Not necessarily them, but something like that.
Proving that this kind of mining is feasible could trigger an influx of profit-minded companies migrating off the Earth. Just one industry that would stake a claim on the vast wealth of space. Not only is the universe a place for exploration, for private companies it's a new resource. The key which will unlock new possibilities in technology, manufacturing, living and working, both at home and beyond Earth. And all of this will be the result of our next giant leap.